Welcome to the Silicon Labs introductory video on creating an example EmberZNet network. This video describes how to create a simple ZigBee Z3 light and switch network using Simplicity Studio and the Silicon Labs EmberZNet ZigBee protocol stack. The example applications use touch-link commissioning to form the network. The light acts as the touch-link target, and the switch performs touch-link commissioning to establish itself on the same network as the light. Once the network is formed, you can use a button on the switch to toggle the light LED and observe the interaction on a console interface to the devices. Before you follow this video's instructions, you should have two wireless starter kit devices connected to your computer. Simplicity Studio should reflect the two devices, and also EmberZNet Pro as your installed protocol. We'll create and load the switch application first. Make sure the device you will use as the switch is selected. Scroll down and under Examples select Z3 Switch. Click Yes and the example opens. You are now in the Simplicity IDE using a tool we call App Builder. You see the starting file for the Z3 Switch example. Tabs across the top provide access to configuration options, but for now just click Generate in the upper right. Once generation is complete, you should see the generated files in the Project Explorer view. Click OK. Make sure the device you will use as a switch is selected. Click the Build icon. The application builds, with progress shown in the dialog and also in the lower right corner of the screen. This will take a minute or two. You can see that the process is complete in the Build console. While it shouldn't happen with example applications, if you have a build error, you will see it highlighted. Next, you will download the example to your device. All example applications require a bootloader, as reflected on the How tab. Silicon Labs strongly recommends that you use a bootloader, even in development, so that memory is allocated correctly. Silicon Labs supplies pre-built bootloader images for several common development platforms. The files are stored in folders under the project folder shown on the General tab. Expand the radio board for the device you're going to use as a switch, because you'll need the part number later. Right-click on the switch J-Link and click Upload Application. Under the folder that was shown on the General tab, browse to App, Builder, your Project folder, the IAR folder. Then scroll down and select the GBL file. Now, check Bootloader Image, Explore, browse up to the Stack Version folder. Then go to Platform, Bootloader, Sample Apps, Bootloader Storage SPI Flash, and click the file that matches your part number. Click Open. Always click Erase the chip. It's just a good practice while you're getting started. Click OK. Load progress is shown in the lower right corner and also next to the J-Link. You know the application is loaded and booted up when you see LED 1 slowly turning on and off. The switch is a sleepy device. The LED is on when it's awake. Right-click the device and launch the console. When the device is connected to its console, the device icon will be green. On the Serial 1 tab, press Enter. You should see a prompt corresponding to the project name. Now, repeat the process for the light application. Click Launcher to go back to the launcher perspective. Remember to select your other device as the target for application upload. Click the Z3 Light example, and Yes. When the application opens, click Generate. Click OK. If the build icon isn't enabled, simply click the device and that turns it on. Click the build icon. As for the switch example, this will take a few minutes. When build is complete, if you expand the device, you'll notice that the part numbers are the same. Right-click the adapter and click Upload. Because you just uploaded the bootloader, it's still the selected folder, so to save browsing, set that up first. You're back where you should be, the part number is the same, so it's the same file. Click Open, and then browse to your application. Go back to the Version folder, App, Builder, the Project Name folder, the IAR folder. Scroll down to the Project GBL file and select it. Remember to erase the chip. Click OK. The application downloads. Like the LEDs for the switch application, the LEDs for the light application signal that the application is working. LED 1 begins to flash, and LED 0 shines with a steady light. Right-click the lighting adapter and select the console. Select the Serial 1 tab and press Enter. You see that the lighting application is working. When the lighting application boots, it immediately forms its own distributed network and advertises itself as a find and bind target. Go back to the switch console. On the switch device, press button 1 to initiate commissioning. On the console, you'll see the process occur, and then an indicator that commissioning has been successful. Now, if you press button 0 on the switch, you'll notice that LED 0 on the light toggles on and off, and you can see the activity on both the switch console and the light console. The light only advertises for a 3-minute window, so if you got interrupted and then commissioning fails, try pressing any button on the light device to restart advertising. Now that you have successfully completed working with the default example applications, you can begin customizing your own. Most of the configuration options are self-documented, so you can explore the default configurations and the effect of making changes. You may also want to watch the video on using the Network Analyzer tool to see more details about network traffic. You may also want to explore the documentation provided in Simplicity Studio. QSG 106, Getting Started with EmberZNet Pro, contains all of the information covered here. The Fundamentals guides provide extensive background information for areas new to you. Finally, for more information about configuring custom bootloaders, see UG266, Silicon Labs Gecko Bootloader User Guide. Thank you for watching.